Okay, so the recording is there. I'm hoping that with your memory of how the lesson went so far, that you'll be able to keep this up. But in any case, please remember, we started with this question off thinking, 3, 9, 27. I feel like there's something going on with that. 2, 8, 64. They are all multiple, or they are all answers with 2 as a base, like 2 to the power of something is equal to 2, 8, and 64. They all work. And so it might be nice to have all the blue arrows in one side of the fraction and all the red arrows on one side of the fraction. So all the potential answers with base 3, I put in the numerator. So 3 is now on top, 9 on top, and 27 on top. And the same thing with the 2's, 2, 8, 64 on the bottom. And then the rest was manipulating exponent laws. Who is that? People are cutting in and out. Okay, let's do number 12 by request. Yeah, now's a good time to continue asking. All right, so question 12. Maybe I can zoom in a little bit more so I can focus my attention on this part. Okay, going in blind. All right, let me go through my thought process. I see that this is 3 to the power of something, and I have 3 to the power of something. And there is a slight difference. And because there is a difference of a value too, I don't even know whether it's going to work or not. I do see that maybe there could be some kind of substitution. Like maybe I could change this into the format of a squared plus, something a plus something equals a 0, right? Like maybe I can turn it into that and turn it into a factoring question, because I've seen stuff like this before, and I know you have too. It's just a matter of how do I change these complex looking exponents? I am going to go ahead and try to change this into a more familiar form. Oh no, that's not true. This is not true. Ooh. This is 3 to the power of x to the power of 1 over 4, isn't it? Wow. And then 4 to the power of, 4 times 3 to the power of x to the power of 1 over 2 plus 3 equals 0. I'm going to give everyone a minute to see if they can figure this out. I think that will work. Why will that work? It is because that is to the power of... Or did I do the other way around? Give me a second. Give me a mental... if that was the case, if I have that to the power... Yeah, I think I did it right. I'm going to give you a second. I think it is 3 to the power of 4, 3 to the power of 4x square root x, not 3 to the power of 4th root. Is that right? Let me take a look at the photo again. Spicy equations. Oh, you're right. I made it hard mode. Not that my version wasn't impossible. But okay, that's my bad. Sorry, everyone. What you had versus what I gave you just now are different. It has just been revealed to me that this is not the fourth root. It's just a multiple of four. It's just four, shoot, four equation, four root x. And this is two root x. Sorry about that. I'm going to have to re-upload this onto the thing as well. Oh, it just makes it so much easier though. Yay. Not that you couldn't do what I just gave you, not that you couldn't do it. But anyways, let's do this again. Okay, but it still stands. I am looking for a way to make this into something like a polynomial, a trinomial, because it's easier, right? So how would I do that? Well, I do notice that this is right, which I could say is the same as, wouldn't you agree? Right, using exponent laws. And therefore I can technically rewrite this as oh, right. And the reason this is what I'm going towards, right? After all the practice you've done so far, the reason why I want this to be my direction is because I can do a substitution. So let a equal 3 to the power of 2 root x, which means it's a squared minus 4a plus 3 equals a 0. This means I can factor a minus 3 minus 1. So a equals a 3 or a equals a 1. Now I wonder how many of these are not going to be acceptable. But yeah, that's the direction we want to go. Sorry about the beginning. I must have read it wrong in the middle of the night, and so I gave you a much harder version than was necessary. But this, I imagine, at your point right now, it still can be a little bit challenging. Again, I am only seeing some kind of relation between these two. I also noticed that there are three terms. So in the back of my mind, I thought maybe there is a way to solve this if I turned it into a trinomial. Right? So don't be afraid. So we have if a equals 3, so case number 1, if 3 is equal to 3 to root x, that means 2 root x is equal to a 1. That means the exponent of 1 is equal to 2 root x. Let's write it that way. That means 1 over 2 is equal to root x. And that means x is going to be equal to, if I square it, 1 over 4. Okay. Case number 2. If my a value is equal to 1, that means 1 is equal to 2x. Oh, well then, there's only one way that I can have a 3 to the power of something equal to a 1, and that is when the exponent is equal to 0. So 0 is equal to 2 root x, which means 0 is equal to root x, which means x must be a 0. I have two answers. And does that agree? Yes, it does. 1 over 4 and a 0. All right. How do you feel, everybody? All right. So here's what we'll do. I'm going to pause the video. I'm going to set you off on a quick 5-minute break to go to the washroom, grab some water, do whatever, refresh. During that time, also, I would like you to take out your Law of Logs handout if you use that as a reference. Get out whatever resources that you will need, and go to our Brightspace and see if you can pull out this handout. It is the extra tangy questions underneath the lesson 7.4. We're going to start working through and hammering through as many of these questions as we can. Okay, until maybe around 10:15, 10:30, at which point I'm going to give you another break and then let you work on the chapter 7 assignment during class time. So I will pause now. All right, so getting started with tangy questions for logarithms. Questions like this where you don't have the base. First thing you might want to do is to see if there's anything else in the question you can simplify. In this particular case, there's nothing. So what do? Well, from our past experiences, anytime you had this, we actually took the time to convert this into an exponent. Think about it. X is the base. If it's to the power of 2, then you get the answer, which is x squared minus 4x plus 12. That's essentially it. And what's fun is that if you understand the basic concept of logarithms and use so in this case, I'm going to call it the inverse technique, okay, which is not really a technique at all. It's just, understanding logarithms. We can use algebra, subtract x squared from both sides, giving us 0 equals negative 4x plus 12. That's it. And all you got to do is do algebra. So I'm going to subtract 12, divide by negative 4, divide by negative 4. X is going to be equal to 3. Done. Okay, that's fun. Number 2 is relatively similar. It does involve a factoring, but it still applies the same idea. What would you do? So this is question 2. I'm wondering if you can do some of the questions that were on the log quiz. Yeah, all the quizzes should be marked. So yeah, we can take a look at it. Do you remember one of the questions? I could bring it back up afterwards. Okay. So number 2, so this is number 1. If I were to do number 2, it's the same idea, but it would be what? 27 to the power of 2 over 3, which is very doable. Don't worry, everyone. And that is equal to the answer x squared minus 8x. I think you can guess that if we were able to figure out what that number is, you'd be able to solve this as a quadratic. Well, I'm going to force myself to not use the calculator. This is the same as 27 to the power of 1 over 3. That is to the power of 2. I split the fraction 2 over 3 into 1 over 3 times 2. Remember, power of a power. And what does that mean? The third root of 27 means a number that multiplies with itself 3 times to give me 27, and that is 3. And what is 3 squared? It's a 9. So 0 is equal to x squared minus 8x minus a 9, which means I have x minus 9 and x plus 1. So the x values the possible x values are positive 9 and negative 1. Okay. So it's gonna be continuing, that's basically the idea. Number 4 is what I'm gonna jump to. What do you do when you have a log inside a log inside a log? And then we'll do number 5 as well. Okay. Clearing. Let's just in case some people are copying this, I'm gonna move this down. I'm gonna use a top space. Here we go. This is number 4. When you have a log inside a log inside a log, there isn't some kind of trick that you can use to solve this. However, just from having knowledge of logarithms, you can use the inverse knowledge. Like you can use the inverse technique from number 1. Log 4. Don't worry about this for now. Log of base 4 of some number gives me an answer of 0. Pause right there. I had someone in chat say, do we have to say that x equals 9 is extraneous? Let me check. This is number 2. Log 27. If x is a 9, that's 81 minus 72. No, that's still a positive number. And then, no, it's good to check. I just assumed that they're both okay, but I could be sleeping. -1 times -1 is a 1. -8 times a -1 is a positive 8. Yeah, both numbers are going to be positive. It's going to be okay. So both answers work. Number 4, log base 4 of something equals a 0. So if I turn that into an exponent, 4 to the power of 0 is equal to that question mark, which is obviously a 1. So bring that back. Whatever was inside this logarithm is equal to a 1. What does that mean? It means log of base 3 of log of base 2 of x squared is equal to 1. Now let's do that again. Log of base 3 of something inside is equal to a 1. And if I were to change that into an exponent, 3 to the power of 1 is equal to whatever that thing was inside. So log 2 of x squared is equal to 3. Let's go one step further. Log of base 2 of x squared is equal to a 3. Which means 2 to the power of a 3 is equal to x squared. Continue on. I'm running out of space. 8 is equal to x squared. So x is equal to plus or minus root 8. And I could test that to see if both numbers work. Well, whether it's a root positive or a negative, it's going to be squared right away. So whatever that number is, it's going to always be positive. I don't mind either number. Both numbers are acceptable. Okay, so here is one way you have log inside a log. Here's one way you can try to solve it. Okay. Any questions so far? No? Going once? Going twice? If you have an issue of typing or you're typing slower, just be like, I have a question, and then I will wait for you on chat. But if the chat is blank and I'm counting down and you're feeling stressed, just type something and say, I have a question. All right. I had a special request of number 5. And this is what I meant when I said, I think I'm reading Sam's mind correctly. I'm thinking Sam was looking at the 2 as a coefficient and 2 as an exponent, thinking, am I supposed to somehow bring this into an exponent? Or am I somehow supposed to bring this down as a coefficient? But wait, I can't because this is not actually a part of the logarithm, so I can't use the law of logs. Does that mean I'm stuck? Or a variety of other rules that you were trying to do. That would have been my first take on it as well. However, I would have caught myself because this is not the same as that, where an exponent is inside a logarithm and I could drop it down as a coefficient. However, what I do notice after taking a second look is that log of base 9x and log of base 9x are common. I am going to substitute. So for number 5, this actually just turns into 2a squared minus 1a minus a 1. It's a quadratic. Albeit it's not product sum. The a value, the first number here, the leading coefficient is not a 1. So you will have to do decomposition or some other form of factoring that you're comfortable with. But it should turn into this, which means the a value is either negative half or equal to 1. What does that mean? It means log 9 of x is equal to negative half, or log 9 of x is equal to 1. And Nathan, this is where you come in? No?
Wait, I'm thinking about it. One of them is extraneous, would be my guess.
Actually, is it? Now that I'm thinking about it. I just guessed because it was a negative, but wait, 9 to the, oh, you know what? No, I'm wrong. That's not true. This both can work, I think. Because 9, so what is x? It means 9 to the power of negative half is equal to x. And 9 to the power of 1 is equal to x. So one of the answers for x is obviously just 9. But the other answer for this is, what's the reciprocal? 1 over 9. And what is a root? There. But negative 1 over 3 can't be in there because that would be a log. So the negative 1 is, so the negative is rejected. So it's just going to be positive 1, a positive 1 over 3. Sam, did that work out? Things okay? I'm going to say the same thing can be said about number 6. Notice how they are common, which means this could be written as a minus 2 a to the power of half minus 3. Or maybe instead we can write it in a different way. Maybe we can say that the square root of log 2x is equal to a, which means this is going to be a squared. There's a lot of different ways you can do this. So please feel comfortable exploring getting it wrong and figuring it out at the end. In terms of getting it wrong, I found a really, really interesting quote that might be useful to all of you. And the quote is this, right? Actually, yeah, the quote is this. Okay. To fail is acceptable, but to accept failure is not. And I thought that was very applicable to all of my students, as well as myself, actually. If you read all the motivational quotes by people like Einstein and Thomas Edison and blah, 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 all the people that are generally very successful or very famous, all of them, there was a difference between the people, normal people like you and me, I suppose, well, more like me. I don't know if you are normal. I don't want to downplay you in any way. But people like me who are normal versus people who are successful, they really shrug off failure as if it's a normal stepping stone towards their final goal where they're supposed, like they are so fixated, they are so convinced that they belong here. They're so convinced that they belong here that if they fail here, fail here, fail here, they're just like, that's fine because I belong here. I'm going to get here. Right. And they keep on failing and they keep on learning from it, learning from it, learning from it. And it's like a self-fulfilling prophecy. And so, even for something as small as this, use it as a way to teach yourself that, hey, failure is a part of the journey, but to accept the failure and say, this is what the end result is, and this is what I amount to is not acceptable. Okay, hope that is useful for you. I am going to move on and look for another kind of question that might be useful. And that was, what do you do when you have different bases? So let's try number 10 together. Number 10, what would you do? Well, I can't even use the law of logs to turn this into a single term because, well, they're different bases. Maybe I can try to change them into the same base. Let's do log 10 of x over log 10 of 3 plus log 10 of x over log 10 of 9, which is a 3. I feel like I've seen this question somewhere before. Did we do a question like this in our handout? I think so. This is log of x over log of 3. Remember, I'm trying to make the denominators the same if I'm actually going to add them. But how do I deal with log of 3 and log of 9? Well, 9 is 3 squared. And using your, I guess, the power law of logs, I can drop down that exponent, turning this into that. And you can imagine if I go ahead and multiply all 3 sides by log of 3, actually, should I do that and risk confusing you? It should be okay. I'm going to multiply everything here by log of 3. So log 3 times log 3, this becomes log x plus log x over 2 log 3 times log becomes log x over 2. So we'll just do 1. And this becomes 3 log 3, which is a number, right? Let's continue on. I don't like the denominator here, for example. I can multiply all portions by a 2, all terms by a 2. This becomes 2 log x plus log x equals 6 log 3. Add that together. This becomes 3 log x equals 6 log 3. Divide. So log x equals 2 log 3. Log x is equal to log 3 to the power of 2, which is a 9. Therefore, x equals 9. It's a bit long. It's a bit long. In the very beginning, it will be long. But as you go through it, I am fully convinced that you'll be able to see that some of you might be able to do the first portion where I'm trying to simplify the fractions in a more concise way. You don't have to do it my way, but this was me attempting it for the first time, looking at this question for the first time in many years because it's been a while. Right? So you could see my thought process. My last bit for today is going to be number 12. Afterwards, I am going to essentially release you to have a break, and then we'll come back to do some chapter 7 questions together. There was a request to take a look at some questions from the quiz prior to your winter break. So we'll see. Maybe we can do that while some people go for a quick break. Can we do number 3 as well from this sheet? Yeah, we can do that. Yeah, I am going to clear this. If you want to see this again, I'm going to go ahead and take a screenshot of this and I could post it up for you. Please let me know if you want to go back to number 10 and because you missed something at a later time. Number 12. Number 12, I have log of base 2 of x multiplying with a different base of x. So what do? I don't think you do anything different than what we had before. When you have a different log base, there's very little you can do for the laws, right? There's very little laws you can use other than changing it to have the same base. So I'm going to turn the first, I guess, portion here, log x over log 2, multiplied by, this would be log x over log 4. And which is 8. And it would be nice to turn this into the same thing again. And you'll see why later. I'm going to take an extra step in turning this into log of 2 times log of 2 to the power of 2, which is the same as there. Because I dropped the 2 down, this becomes 2 log 2, and I have log 2 twice. So it's 2 times log 2, which is an 8. From here on out, it's all algebra. I am going to leave log x to the power of 2 here. I'm going to take all of this to the other side. So that becomes 16 log 2 squared. And then I am going to, how about I simplify this? No, square root both sides. So log x is going to equal 4 log 2, which is the same as log 2 to the power of 4. So x is equal to 2 to the power of 4, 2, 4, 8, 16. The answer would be 16. While some of you are copying, let's see. This was change of base. This was a common log for a denominator. And then the rest is just algebra. Okay. I'll give just another minute for people to catch up if they were not copying but just listening. My final question is going to be number 3. That one, let me move this entire thing here so you can still see it. Let's see, how would I do this? 2 to the power of 1 equals this. So all of that equals a 2. So that's 1 to the power of 2. Oh, Joseph, I totally think you can do this. I really think it's the same idea as number 4.
I did it and I got
Uh-huh.
an answer, but I got an extra answer as to like the answer key.
There's more answers than what
I
was
got
available.
3 and 2.
Oh, it could be okay. I might have gotten something wrong. Let me take a look then. And also, someone told me that there on the answer key here, there's also a 1/16. How could we find that? Let's see. First off, let's see. Does 1/16 work? One over 16. Okay. Log of 1/16 divided by log of 1/16 divided by log of 2. That's multiplied by log of 1/16 divided by log of 4. Oh, it does work. What did I miss? Mm-hmm. 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 Oh. Thanks, Josh, for pointing that out. When I did do the square root, when I square rooted both sides, right? Since it is a square root of both sides, the answer to this could be plus or minus, right? So one side could be a plus while the other side could be a minus. Therefore, if the answer was a -4 log 2, then this would be log of 2 to the power of -4, which means x could also be 1/16. That's where the other answer was. That was my bad. You have to be careful of that. And then let's investigate number 3 to see if there were other answers there. Clearing. Now I'm antsy to see if we made a mistake for number 3. So log 2 of something equals 1. That means 2 to the power of 1 is equal to log x minus 1 bracket 3x minus 5. This means that the base x minus 1 to the power of 2 is equal to 3x minus 5. And the rest is algebra. So this becomes x squared minus 2x plus 1 equals 3x minus 5. Subtract, subtract. X squared minus 5x plus 6 equals a 0. That means x could be -2 and x is -3, which means x equals 2 or x equals a 3. Is it the same as you?
Yeah, and you actually just did it the exact same way I did it.
Okay. Now, the reason I think that this is rejected is because it wouldn't make sense for a logarithm to have a base of 1. Does that make sense? So we're testing it.
Yeah.
So log x minus 1, 3x minus 5. There are two different places where the x could be. If you plugged in a 2 here, this becomes x minus 5 equals 1. That's okay. Having a value of 1 is not a big deal. X equals 3, that's a 9 minus 5. That's also okay. However, if you plugged in a 2 as a base, we would have a log of base 1, 3x minus 5. And you can't have a base of 1. It doesn't make any sense. Because if you were to change this into a exponent, that's like saying 1 to the power of something gave me 3x minus 5. Right? Like the answer is always going to be, it could be anything. You get what I'm saying? You wouldn't know what the exponent is because any number will still just give you a 1. So it's undefined. There are way too many answers. That's why I believe this is rejected, and so this would be an extraneous root, and only x equals 3 is accepted.
Okay.
Right. In the worst case scenario, I guess you can argue it by saying, by definition, a logarithm cannot have a base of 1. You can say that, right? Or the base of an exponent or whatever. It can't be a 1.
Mr. Kim,
Yes.
would the same be true if the base of the log was equal to 0?
Yes, the base of a log or even a base of an exponent cannot be a 0. 0 to the power of anything, it just doesn't make any
Yeah,
sense.
it's
It just becomes
undefined,
0.
right?
Yeah.
Yeah, okay.
Curiously enough, and everyone's gonna hate me for it, it's still going to be 0 to the power of 0, though, is still going to be equal to a 1 by mathematical theory. I'm not going to go into that conversation.
That sounds like a conversation for the last day, or when we just don't have to worry about it. But
That's not a conversation you have like when you're really, really bored, unless you're really into math. But we'll leave that for another day. Just thinking that. So now it is now 10:20. I really want to send you off on your break, and we will reconvene in 15 minutes. When we do come back, the rest of the time is yours to ask questions or to work on your Chapter 7 assignment. There was a request to, where is it? To look at your Chapter 6. I guess it's the, let's see, which quiz? You guys were doing C. So there's a request to do some of these questions. I think it was Yusuf. Yusuf, do you have a specific question in mind when you look at these questions? Which one were you wondering about?
Is that the one we had?
Yes, this is version C. There is version C and D. So some of the questions might be a little different. But I mean, it is what it is.
Yeah, let's just do.
Well,
Can we do-
I'll leave it up here for you to take a look and see if you want to even retry. I'm gonna send everyone off on their break. Clock. There it is. I'm gonna throw 15 minutes on the clock. And yeah, take it right now. We will see you at exactly there. Why is it so hard to do this? Okay, 10:36. Okay, I'm gonna imagine that people are gonna slowly trickle in. I'm gonna get started on this question. Okay.
Sorry. It's actually question 3, like 1, 3.
Oh, I see. Mm. Okay. Oops. Let's see if I can get some space. Let's see. What would I do? Okay. I would have probably left that alone, but turned this into a single logarithm. Turning this into yeah, and then plus that and plus that. Let's leave that alone for now because I just want to simplify this portion. If I did that, this essentially becomes negative half log of e squared minus b squared. And this would be, well, log 2 of a squared minus b squared, and that to the power of negative half, which I can do that as log 2 of 1 over square root of a squared minus b squared. And I look. Oh, none of them actually simplified it this way. In fact, the only one of these options that have a square root in the denominator happens to be this one. And I think that also makes sense because if you take a look, this is an addition and that's an addition. They would end up, if I multiply them with each other, they would end up in the numerator anyways. So if my hunch is correct, again, I can confirm it, but I feel like number 3 is going to be C without me even doing any other calculation, right? It's the only option out of the entire choices, all out of all the choices that have a square root in the denominator. So I'm not going to calculate any further because it's a waste of my valuable time if I were to do a quiz. That would be my strategy. Right. Hope that's good. I am going to switch gears and get to a request. Question 6 from the Tangy questions. Okay. So what I am going to do, it's another form of substitution. And in my head, it makes sense. But since you are requesting this from me, I am going to try to do it in a more simplistic form of substitution. I'm going to let A equal square root of log x. Okay, I'm not going to make the substitution this. I'm going to make the substitution that. And here's the reason. If I have this as my substitution, then I can also argue that the square of this is going to be that, which is right here. So instead of making log base 2 of x my substitution, I'm going to make the smaller version of it, the square root form of it, my substitution, because that automatically makes the first term simplified as well. So long story short, this becomes a squared minus 2a minus 3 equals a 0, which allows me to factor like so, which allows me to calculate a as a 3 or a negative 1, which when I bring it back to my substitution, so square root of log 2x is equal to a 3, or a square root of log 2x is equal to negative 1. Haha, this cannot happen. Therefore, this one is an extraneous root. And all that's left is to solve this. If I square both sides, log 2x is going to be a 9. That means 2 to the power of 9 gives me the x. X must be 2, 4, 8, 16, 32, 64, 128, 256, 5, 12. There. Perfect. And that's it, everyone. As we get to the combined equations, I'm not going to do them for you unless there is a special request sometime in the future, like tomorrow, for example. But even without doing the special combination equations where you are using both your exponents and your log skills, like take a look, right? In your exponent is a log, dun dun dun, or in your log is an exponent, dun dun dun. Yeah, give that a try. It's going to be a little bit more of a hard mode. Everyone else, for the remaining period of time, I will ask you to dedicate yourselves to, where is it? Where is it? Oh, did I not open it? Dedicate yourselves to chapter 7. Where is, did I not even download it? It's on the website then? Clearly, I am so organized. I'd like you to dedicate yourselves to the assignment, which I'm sure you already have. But if you don't, it's in the content section, number 7, right here. Okay, get started on it. As I said before, from yesterday's lesson, you essentially have all the tools you need to actually solve it. The format is lost here. So I'm sorry, I'm pretty sure I downloaded it somewhere. I'm positive I downloaded it yesterday to show you. Okay, found it. There. Here is, having roots instead of exponents, turning that into an exponent will help. This is definitely a case of substitution, so that it makes your life easy by turning into a polynomial. Same thing here. Here is a log where all the bases are the same. What would you do? Here is a log where I have a root, which is basically an exponent. How would you solve that when you have an exponent inside a log? And here is when you have a square on the outside and a fourth root on the inside. But clearly this is log 10, and this is y, and that is also a y. So there must be some way to relate these two. It'll require some deeper thinking, but see what you can do. The remaining time, we have 45 minutes together. I will sit on my butt here and wait for questions.
Mr. Kim,
Yes.
your number 6 is different than the one that I have. I don't know. Mine has like two, like a log and then another log on both sides of the equal sign.
Same here.
Oh, right. What you probably have is this. This one, correct?
Yeah.
Yeah.
The reason why it looks a little different is because in Google Docs, the formatting is messed up compared to Microsoft Word. So hopefully you will have some kind of program that opens up docx files correctly. What you can do is go to File and download as a Word document. That will fix all the logs. If you cannot do that, you know what? I'm not even gonna wait for your answer. I'm going to go ahead and turn this into a PDF, and you can download that PDF. Will that be all right?
Yeah, thank you.
Yeah. Just give me a quick second and it will be up very soon. Let's see. Show and log equations assignment, CD version. Okay, should be good. And let's see if I could fix this directly by uploading a file directly. Insert stuff from my computer. Desktop. PDF version. Let's see if that works. I think it works. Please try that one. Go into our Brightspace and see if this version works for you. Will we get marks off if we solve them using different methods? I'm a bit confused what you mean by different methods. If you're asking if you solve it using a different method to what my answers might be, the answer is no. It will be marks off if your method misuses the laws, I suppose. Right, like uses a law when the conditions for using that law were not met. Okay.
The
But-
PDF works. Thank you.
Okay, great. Right, so everyone, I am going to go back to playing some concentration music for you in the background. If you don't want to hear it, then mute. But I will be here for as long as you see me on the camera. You could either type or just speak out, and I will do my best to help you within my what's the word I'm looking? Legal means? I don't know. Okay, let's do it. Okay, this classical music thing is a little depressing. Is there more like? All right, here we go. Sure, Joseph. I don't mind that. I suppose, again, I'm probably going to dismiss you closer to 11:15 anyways, so that you can have a full hour lunch. This time is yours. Just know that I will be here to answer any questions. Okay?
Thank you.